Good afternoon, everyone. My name is Albert Palacios, and I am the Digital Scholarship Coordinator here at LLILAS Benson, Latin American Studies and Collections. I want to thank you for joining us today for our spring installment of the LLILAS Benson Digital Scholarship in the Americas Speaker Series. Each year, the LLILAS Benson Digital Scholarship Office showcases the work of scholars who are engaging digital lenses to innovate scholarships on Latin American, US Latinx, African diaspora, and indigenous studies. Today, I have the great pleasure to introduce Dr. Frederico Freitas, who will share with us a collaborative project he co-leads as part of the Visual Narrative Initiative at North Carolina State University. The collaborative project uses machine learning and computer vision techniques and a novel interactive visualization tool to provide street-level insights on the effects of the Great Recession from 2007 and 2009 on urban neighborhoods in the United States and Latin America. Dr. Freitas is Assistant Professor of Latin American and Digital History at North Carolina State University. His scholarship lies on the intersection of environmental and digital history, and he has published on the history of national parks in Brazil and Argentina. Dr. Freitas is the editor of Big Water, The Making of the Borderlands Between Brazil, Argentina, and Paraguay, which was published by the University of Arizona Press in 2018. And he's also the author of Nationalizing Nature, Iguazu Falls and National Parks at the Brazil-Argentina Border, which was published this past year by the Cambridge University Press. Also, it recently received an honorable mention for the Latin American Studies Association's Bryce Wood Book Award. So without further ado, I present to you Dr. Frederico Freitas, and I give you the word.
Thank you, Albert. It's a pleasure to be here talking about my work. I would like to thank you for this invitation, and also the LLILAS Benson Latin American Studies and Collections for hosting this event. I'm gonna share my screen here. Just give me a second, please. Do you all see my slide? Yeah.
We do, yes.
Thank you. So when I was preparing this presentation, I changed my mind a little bit, and I decided to talk about not only about my work with computer vision and urban change, but also to talk a little bit about the previous work that I've done before, and just to give everybody a sense of the things that I'm doing and where I'm coming from. So the title of this presentation is a little different from the one you saw in the flyer. Is GIS, Computer Vision, and Spatial Change in the Americas. And in this presentation, I divide this presentation in two parts. One, I'm going to talk about GIS and remote sensing in Latin American environmental history. This is the core of my work. This is the book that I published last year. Has a lot of this type of work in it, and this is mostly a work where I don't work. It's mostly my individual work as a historian and as an environmental historian of Latin America. It's not totally individual because I had the help of research assistants in the past, but it's the work where I'm the only principal investigator. And the second part, it's related to the previous title of the talk, Design and Computer Vision in Urban Studies in the Americas. And that's the work that I've been doing with my colleagues in the Visual Narrative Initiative here at NC State. So I'm going to start with my part one. GIS and remote sensing Latin American environmental history. And I'm going to talk about two projects that I had within that using GIS to study environmental history in Latin America. So the first one is the work that I've done that I started with my dissertation. I did my PhD at Stanford And when I was at Stanford, I worked a lot at the spatial history project there. And eventually this dissertation evolved into this monograph, Nationalization Nature, Iguazu Falls and National Parks at the Brazil-Argentina border. It was published by Cambridge in their Cambridge Latin American Studies series. And in this work, I focus on this border area between Brazil, Argentina, and Paraguay. And I focus on these two national parks that were created in the 1930s by Brazil and Argentina. They are separate national parks, but they are created around the same time. And they were created initially to protect the Iguazu Falls, which are this famous complex of waterfalls that are divided by the border between Brazil and Argentina, similar to the Niagara Falls and here in the United States and Canada. And one thing that is interesting about the history of these parks, I talk about the history of the parks, why they were created, what people had in mind when they created the park, but I also talk about the actual spatial history of the parks, how the parks were established as these spaces of protected nature. And one of the things that I talk is about this time when a little like 20 years after the parks were created, when people from Brazil, I call them settlers because they call themselves settlers, white Brazilians of German descent, coming from other states within Brazil, they arrived in this region and they started to occupy land inside the Brazilian side of the park. So I have a chapter two chapters about that in my book. And this is a aerial image that shows on the bottom part you have the Brazilian park and the areas that were occupied by these Brazilian settlers inside the park. And the upper part you have the Argentinian park, and the river is the border. So one of the things that I wanted to study when I was looking for primary sources to reconstruct the history of land use in this park, especially with the fact that you have settlers coming and establishing themselves inside the park in the 1950s and 1960s. I wanted to find sources to study that. And when I was in Brazil a few years ago, in the archives looking for sources, one of the things that I stumbled upon was this box of film, photograph films, and of these aerial images, this aerial survey that was carried out by the state of Paraná in Brazil in the 1950s. In the 1950s, the state of Paraná did this aerial survey of the entire state. The state of Paraná is in Brazil. And they had this films of these images. So the archive allowed me to hire a company to scan this films, and then I compile a collection of 235 images of this border area in Brazil that encompass the park and also encompass the areas outside the park. And these are really high definition imaging, and they would allow me to understand what happened with the park, what was the stage of the landscape, of land use, of land cover in this border area in 1953, after the national park was created, but before settlers arrived in the area of the park. The same archive also had another collection of images from another survey that was conducted also by the state of Paraná from the same area, and from 1980. And that was also an interesting set of images because they showed this border area after most of the colonization of this border area had happened, and after the settlers had left the area inside the park. So this is one of the corners of the park. This river is the border between park and non-park area, and it shows before in 1953, you can distinguish between one side and the other. They are all covered by forest, and this is subtropical Atlantic forest in Brazil. It's different from the Amazon forest that people, when they think about Brazil, they think about the Amazon forest, but this is a different type of environment and biome. but it's highly biodiverse, and there's only a little bit left of that. And in 1980, you have kind of like the same area, and outside the park, it's mostly farming and small family farms, and inside the park, still protected. But what I was interested in was this area here that I show. This is a mosaic of the images from 1980 that, and you can see the area inside the park, in the upper part of the river. That's the area where settlers were living. So I wanted to map to understand where they were living and how much of the area inside the park they had cleared during the about 20 years that they lived inside the park. So I geo-referenced all this different two sets of aerial imagery, from the one from 1953 and the one from 1980. I did that with the help of research assistants. And then I wanted to also to find a source for the time that settlers were actually living inside the park, because I have the moment before, the moment right after, that you can still see the area that they cleared, but I wanted to find something, a snapshot of the time that they were inside the park. So I went to the USGS website, and they have all these images from the Corona Spy Satellite Program, which was a program that was established by the US Air Force and the CIA in 1950s. And for many years, these images were secret, but then I think it was the Clinton administration declassified these images. And what's interesting is that these images today, they're used by people who do like remote sensing, who do studies in land use and land cover. Also, they are used by archaeologists who wants to see the state of the landscape before much of like present day development happened. But historians like me were not using this type of resources. So I only know one historian who uses this Corona images. So I decided to use, and I went to the USGS, and I found some images from this area. I found some images from 1967, which were ideal because that's kind of like the height of the occupation of the park by the settlers. And a year after that, settlers were informed by the Brazilian military dictatorship that governed Brazil at the time that they were about to be evicted from the park, but they would receive compensation. So one of the things that I wanted to test was whether or not the news that they would receive compensation contributed for an increase in people entering the park and squatting land in this period between receiving the news and the actual process of eviction starting in the 1970s. So I geo-referenced all this satellite and aerial imageries, and I traced the land cover using these basic categories of forest, cropland, urban, natural field, and water. And I did that for all the three different time periods. And also I added one for 2014 that I use modern day satellite imagery. So this is some of the my findings. You have here 1953. Most of the area in this borderland was still covered by this Atlantic forest. You already have the beginning of settlement there with this the orange areas. And in 1968, you have much more area that was cleared for farming, especially outside the parks, and also a little bit in Argentina. Argentina is the lower left part of the map. But you also have a little bit of like people, not a little bit, but some people already living inside the park. And 1980, the area outside the park is totally changed. And inside the park, you have the maximum area that was cleared by the settlers. You also have some urban areas in this borderland. They're growing. That's the purple polygons. And finally, in 2014, you have a lot of the area that used to be cleared inside the park was the forest recovered that area. And you also have some changes happening outside, including like more area outside the park that was forested in 2014 than in 1980. And I talk about that in my book. And I also used these aerial images to do a more qualitative assessment of the landscape change in this border area. So in my book, I focus on different sections of this borderland, and I use these aerial images to talk about before and after, and to tell stories about things that are happening on the ground. So I talk about these different towns that are appearing in the borderland. I talk about these different sections of the limits of the parks and how they changed because of the colonization of this area. And one of the things that I do it's also interesting is that when I started my project on these border parks, one of the things that I was looking for in the archives, the written archive, the type of archive that historians use, was evidence of the presence of indigenous people in this borderland area, indigenous people living inside the area that eventually would be declared as parks in the 1930s. And although I found lots of references to indigenous people living in this borderland area, I didn't find many sources that connected indigenous people to the actual area, to specific places inside the parks. So the only thing that I had was some interview, some ethnography produced in the early 1980s by some Brazilian anthropologists that indicate some of the places that they might have lived before the creation of the park in the 1920s. This anthropologists, they went to these communities that now live outside the park, and they interviewed the elders, and they indicate some places that they might have lived inside the park, but none of these areas were actually very precise. So I used some of these images from 1950s to find places, some of possible places that where these indigenous communities could have lived when the park was created, and a few years after its creation, before they were eventually evicted. So this is one of the projects that I did using GIS to do environmental history of Brazil and Latin America. So my next project, my next new project is about Brasilia. Brasilia is the modernist city that was created and constructed by Brazil in the 1950s, was dedicated in 1960. And that Brasilia is like this very modernist city that they built in the middle of the savannah in central Brazil. Before Brasilia, the capital of Brazil, used to be Rio. And that I'm interested in. When they built Brasilia, they also established what they call the federal district, which is something like the District of Columbia, but much larger. It's a political sub entity that is not a state. It's something between the state and the territory, kind of like the District of Columbia, but it's the size of Delaware, so it's pretty big. So I'm interested in investigating the environmental history of the city of Brasilia, and also the federal district that was created when Brasilia was built. So because I already had worked with corona images, I went to USGS to look for corona images, and I did find some corona images from 1963 that covered the area of Brasilia, but as you can see here, they're not very high definition. I think the 1960s images from this project, from this spy satellite program, they're not very high definition. But I did find some from the 1970s, early 1970s, even before Landsat, that was the most common, the first widely available commercial satellite service. So before that, I found these corona images that are high definition, much high definition than usual Landsat imagery. So I did the same thing that I did with my other project. I georeferenced these images, did the mosaic georeference, and calculated, classified the land use, the land cover of this area. And this is something that I'm still working on, so I don't have any conclusions yet. I'm still writing, thinking about whether or not I'm going to write a paper or a chapter on a future book. So I'm still working on that. And I used Landsat to create all these other land use areas. So I'm still thinking about the role of protected areas within the federal district. So I'm still working on that. So these were two projects that I'm the main PI, and then I've done a lot of this work by myself, but I also had help from other from research assistants. But in terms of like designing the projects, I did all by myself. But in the case of the second part of this presentation, this is all work in collaboration with some of my colleagues in the Visual Narrative Initiative. And the Visual Narrative Initiative is a cluster that we have here, interdisciplinary cluster that we have here in NC State, that brings together people from history and some people from English, computer science, design, and electrical and computer engineering to do some of these projects that are more like digital humanities. So these projects, I collaborated with colleagues from other departments here at NC State, and we designed them together. So I'm going to talk about Urban Panorama, which is the main umbrella project where we're thinking about using computer vision and machine learning to analyze images from the urban landscape, the cityscape, to analyze large corpuses of images. So these are the core members of the Visual Narrative Initiative. That's me, Arnav Jala in computer science, Todd Barrett in art and design, and Matt Wu in electrical and computer engineering. So the idea was of this project was to go beyond the normal use of GIS and historical scholarship. One of the problems with GIS is that when you use GIS to try to understand the reality of past societies, GIS only looks at like a city or a region from above. So one of the things I was trying to understand is to use some computer means to understand the past and how people experience space in the past, but from a different perspective. So the idea was to understanding urban change. Now, I also wanted to focus more on cities at the street level. So we thought about using photographs of streets, of streetscapes, computer vision, machine learning, some GIS to do that. So we started with the first test case of Raleigh, North Carolina, mostly because We live here. Our NC State is located in Raleigh, and we had some access. We worked with the State Archives of North Carolina here, which is it's located here in Raleigh, and they had been digitizing images of Raleigh, historical images of Raleigh from their archive, and posting them on Flickr, on their Flickr account. So we talked to them, got their permission, and started to scrape all the images that were tagged Raleigh from their archive, and to see if we can build a corpus of images of streetscapes of Raleigh that were historical, and see if we could use that to test some use of computer vision to classify, analyze, and these images, maybe compare them to present day imagery from Google Street View, that kind of thing. So we downloaded all the images that they had like 29,000 at a time in 2017. They keep like uploading, but in 2017 when they started this, they had 29,000 images in their Flickr account. We downloaded about 4,000 images that they had tagged as Raleigh. We used Google Cloud Vision API to tag all the images with like things like images that show like outside places, facades, places, to try to select all the images that could be of streets and streetscapes. So we end up with about 1,400 images that were images of Raleigh streetscapes. And then we started to geolocate manually with some research assistants here. Geolocate manually all these images, find where they are in today, using some of the metadata that come with the image. The people at their archive, they uploaded, they included a lot of metadata in the description of the images, and using some of the knowledge that we have of the city. And eventually we end up with almost 700 geolocated images, historical images that we could use. And then we did some tests trying to see if we could compare and build like a system where it would find the matches between historical images, places in the historical images, and places in Google Street View images. We advanced a little bit with that, but the problem with that is that it was hard to train, and then we're using computer vision neural network algorithms to train to find these connections. And the problem was that our collection of images, of historical images, our corpus of images was too small to train. There's also other issues with this corpus of images that we created from Raleigh. One was that it was concentrated in a few famous landmarks from Raleigh. So there's not much variety in terms of like places that it showed. There's only a few small group of buildings that were repeated in the images, and a small number of streets that appeared over and over again. So we decided to pause this investigation with historical images and focus just on the Google Street View imagery. So what I'm gonna talk about is this other project that we did, where we started to use Google Street View images to understand how the Great Recession of 2008-2009 impacted the urban streetscape, and then use imagery from Raleigh from different years that was captured by Google Street View. And for that, we have me, Arnav Jala, and in computer science, Todd Barrett in design, and Yu Chun Cheng, who was a PhD in computer science. And this was a paper that we submitted to the AI and Society Journal and has been reviewed twice. So now waiting for the response for our second group of revisions. So one thing it's interesting for historians, maybe for historians of the present times, is that Google Street View started in 2007, started collecting images from the streets, and it kept collecting images and expanding their scope in terms of the geography and in terms of the number of cities and area that they capture. So it turns out that today they have this really interesting archive of images of different urban places that show these places in different points in time. Like in this case of this slide here, you have New York City in 2009, in 2021, the same street, Mexico City in 2008, in 2021, Sao Paulo, Brazil, where I was born in 2010 and 2021. So you have all this very rich source of images of cities from all over the world that historians that are interested in more contemporary present day changes could use, and if they manage to use some all sorts of different techniques, including machine learning and computer vision. So we draw some inspiration from a series of studies and projects that in the past 10 years have used Google Street View images to analyze cities. One was Place Pulse 1.0, where they analyzed two cities, two in Austria and two in the US, New York City and Boston, and they used crowdsourcing to classify images based on pair of images. So the people who were in the crowdsourcing project annotating images, they would receive two pairs of the images, then they would have to choose which one was, the question that they have was which image looks safer. So they have to choose one of the two to be the one that looked safer. And there's also Street Score, which use all this corpus of annotated images from Place Pulse and use it to train some algorithms to classify a bigger corpus of images from other cities, and they found out that with the images, the annotated images that they had, they could only classify images cities that were similar. So they were only able to classify cities in the Northeast and Midwest because they only had initially images annotated from New York City and Boston. And with Street Change, they did something similar to what we are trying to do. They used Google images from Google Street View from two different time periods. They annotated that with computer vision, and they created a score where it was positive. There was an upgrade in the perception of these places, and it was negative. There's a decline. And Place Pulse 2.0 was a project that they started, but I don't think they finished. But they had this plan to expand to 56 cities in 28 countries all over the world, using crowdsourcing machine learning to annotate these images. Then they have a series of different questions that they would ask the people who would start annotating. So with our project, we draw inspiration from all these different projects, and we kind of like use that approach and methodology and updated that with some different algorithms and some different, a little bit of different methods, and also trying to apply that methodology to it's a specific question in this case, how urban change affect the landscape of the cities. So use Raleigh as a test case. We crowdsource annotation with a smaller sample of Google Street View images of Raleigh, and use the annotated corpus to train an algorithm to create metadata for a large corpus of images of Raleigh, and then compare that to socioeconomic data. So this is the map of some of the images that we scraped from Google Street View from Raleigh. We had 56,000 images. On the left, you have the blue markers are the image that we have in our collection from Google Street View image, and the red markers are the historical image that we had for our first phase of this study that we didn't actually end up using much. But yeah, we have this large corpus of 56,000 images. We had to, for each Google Street View image, we have to transform those images into 4 different images, because you download one single archive, one single file for the 360 image, and then you have to flatten them out and cut them. So we selected only the images from the left and from the right side of the street. And we had 6,000, we created 6,000 pairs of, we get a subsection of our 56,000 images. With the subsection, we sample. We created 6,000 pairs of street level images, and we used Amazon's Mechanical Turk to ask people, annotators from United States and Canada, 5 different questions about safety, wealth, age, maintenance, and occupancy from these 2 pairs of images. So an annotator would be asked which of these 2 images looks safer. We had to either choose A, B, both, or neither. You use the true skill. We ranked, and then after we did all this annotation, we ranked that with true skill algorithm, and we use that to predict what would be the ranking of the images that were not annotated, and then we ranked all the images for an entire data set. This is a slide that Arnav, who's a computer science, did. He was trying to explain why this Bayesian ranking algorithm was interesting to use, the one that you used for this study. There's a series of features like it's more interpretable, you can control. But I'm gonna skip this one here, because lots of parts of this project are and things I'm not a specialist, so I'm going to talk more about the things that I know better. Anyway, we had a series of preliminary results. We analyzed the distribution of these different ratings based on the images in 4 different quadrants in Raleigh, and then we tested these 5 dimensions for correlations for household income data for 2 periods, and we find some moderate correlations for some of the indexes and low correlation to some other, like occupancy. And we realized that it shows us some things that we already knew about Raleigh. It shows how some parts of the city that have been gentrifying, you have a perception of age, the age of the streetscape higher, newer, and these places that have been gentrified, and also perception of wealth and safety. So you have that, and you have the change between the two periods that we used. So, and we're still working on that, but now we are working to expand our project to 15 different cities, and 5 in the US, 5 in Mexico, 5 in Brazil, and to use this method to think about the changes in the streetscape before or during and after the Great Recession. There's I listed here some challenges. We in this next phase of the project, we're trying to think in terms of neighborhoods, the effect that a neighborhood has into these changes in perception, into this in these different indexes. And there's challenges in terms of, like, first, the chronology of the crisis is different in these 3 different countries. For example, in Brazil, the economic crisis happens much later than in the United States. The United States recovers much faster than Brazil recovers from its own economic crisis. There's also the issue that we are basically studying the perception of these places, and perception is different from the actual phenomenon. So we need to deal with that. And when we analyze the results of this study, there's also the problem, the issue that economic disruption many times take years. There's an inertia in some urban spaces, and it takes longer for these effects to appear on the landscape than in some other non-visual, non-spatial index of social change. And also the challenge of defining a neighborhood. What are the boundaries of a neighborhood? What's a neighborhood? So finally, I'm going to talk about this other project that I have with Todd Barrett in design. That is, we're trying to build an app to deal with this large collections of urban images that we have been dealing. So it started first with these plans to build an app, an online app with that would allow people to help systems of image analysis to parse different features of these images and to compare to, initially we were thinking about comparing historical image to a present day image from Google Street View. We never actually implement this. And this is another version of that. But then we come up with another idea of, like, since we have this large collections of georeferenced images, maybe we could create an app to allow people to navigate through their collections, that a system that would show the collection on the left panel as a cluster of images that were clustered by image analysis algorithm based on features of the images, and on the right the same collection of images but as points on a map showing their location. So we did I'm gonna skip this. We did a prototype of this app, and I'm going to show you what is a video, and I'm going to explain what this is. So this is the prototype of this app that we created. On the left, you have all these images of Raleigh that we extracted from Google Street View, and then we cluster them based on similarities of the images, and we organize them on this grid. Is an artificial grid, but it makes much easier to see what they do. And you can zoom in and zoom out, and you can look at the images. And if you select one, let's see, when you select one of those images, you can see a point appearing on the map on the right that shows where the image is located. So there's a correlation, a connection between what you're doing on the left panel and what you're doing on the right panel. But another thing you can do is to, so let's say you wanted to select a cluster of images that you think in the cluster side are similar. So you can use some of the tools to select that cluster, just like tracing and boundary around that cluster, the cluster of images of like brick buildings. And you apply that, and it would show on the right panel is located, where these places are located on the map of Raleigh. So another thing you could do is to alternatively select an area on the map and see where the pictures of those areas are on the left panel on the cluster side. So I selected an area off of downtown Raleigh, and it showed that there's no common visual characteristics uniting all this area. So I'm going to select another area. This is sorry. Select this area here, and it shows on the left side. And I can export the selections and upload the selections, export as XML and upload them. And finally, we had some presets. These presets are misnamed. I have a preset churches, but it's actually brick buildings. So that's it, actually in NC State campus. And now if I select NC State, these are actually churches in Raleigh. So yeah, and this app is not online yet, so you guys cannot access that yet. So this is what I have for you today. So I'll be happy to talk to you to answer questions and comments.
Thank you very much, Dr. Freitas, for a whirlwind of work that you've been doing. It's incredible. I have a lot of questions myself, but I want to be sure that I open the floor to our audience. So if you have any questions, please pose them in the Q&A option, or you can also put it in the chat, or you can just unmute yourself and ask the question to our invited speaker. Well, I'll give people a few minutes to type it up. But in the meantime, specifically about the app that you just showed, can you talk a little bit more about how does the how are the images organized? You know, is there a particular access point in terms of the particular? I know that there's variances in terms of the architectural style and how they're represented in the pictures, but how are they organized? I guess I'm trying to understand how we can use it to maybe discern certain patterns.
Yeah, so this was so when we classify the images, you have a multi-dimensional matrix. And what we did was to reduce some of the dimensions to transform that into a 2D matrix. Mm-hmm. And once we did that, we forced those clusters into a grid. It's an artificial grid. I have some images. I have a slide here. I'm going to show you to understand what we did. So when we first reduce the dimension from 3D or more dimensions to 2D, you get something like this on the upper right. And then we forced that into a grid, mostly because we had a really hard time from a design standpoint having something that was not on a grid to select and do all the things that we wanted to do with the tool. It's a forced grid, so most of the things that are similar are going to be close together, but things that are not similar also close together, especially at the boundaries of the clusters. So things that were not necessarily be close together, they're like, imagine I have 3 different clusters, put them together, so the boundaries get much closer. They touch each other in a way that in a 2D representation of the clustering they would not touch. So that's what we did.
Thank you. Estela has a question. Hi, how can one access the archive of Google Street View images from different dates or years? And I'm going to add to that question because I was also wondering about that. What restrictions are you finding that Google is placing on you all in terms of how you're using the images, or if there's anything related to privacy or et cetera, or other rights?
Okay. That's a great question. So we read the terms of service, and I don't remember the details, but I think that Google is fine if you use their images to do research. We haven't published any of those images. I mean, I'm showing to you now, but we don't have those images. That app's not online, so we're not reusing those images in anything other than just to do our own research. I know some of the projects that we showed that inspire us, they did build some online visualizations where they use some of the Google images. And I know that Google is kind of like okay to allow people to use, and academia to use their images, even if it's not like for a for-profit use. But we haven't gotten any like official permission from Google to use images. That's why we don't have that app online for people to use yet. It's just internally, we've been using internally. So Google has an API. So if you go to Google Street View, there's I'll show you here. It's kind of interesting. It's something that some people might not know. Let's go to Google Maps. And you use Google Street View on a browser. Where's my? It's taking time. Okay. Let's put this guy here somewhere. Okay, so this image from, okay, this is not, let me change one from one produced by Google. Okay, this image here, downtown Raleigh, if you look at here, it was produced in 2022. If you click here, it shows you a timeline of all the different images that they produced in this location, from the first one in 2007 to the last one in 2022. And if you click here, put this in 2007 and click here, it changes to how this area was in 2007. So they had that for all different cities, like for cities in Mexico and Brazil, all the places. If you go to Wikipedia has a page where they have like a timeline of the cities that they cover and when they started covering those cities. So they have like year by year all the cities that they started covering. So 2009, you have the first cities in Mexico. 2010, they had the first cities in Brazil. So that's a very, 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 very interesting source to do all sorts of studies. And I think people should use that more and more as they kept like adding adding images and time passes, there's be more and more images. And Google has an API that Google Street View has an API that I was not the one who scraped these images. So I don't know the details of it, but some of my colleagues did that, and they just downloaded a batch of images and started using it.
Definitely learned something new today. I didn't know that you could actually look at the different years in Street View. That's really awesome. Any other questions that the audience might have? In the meantime, y'all can type them into the Q&A or in the chat, but I have another one here lined up. So you're considering obviously the economic element, right, of that affected the urban change, right? The urban fabric, the urban landscape as reflected in street level imagery. Are you looking at any other factors that might have affected either the maintenance of buildings, right, or just in general the reconstruction of certain areas? Are you considering other elements besides the economic aspect?
Yeah, I mean, I'm a historian, so I'm interested in considering all sorts of like different things, cultural, policy, and all history. History of places is always local history. So you have global phenomena that affects that, like a global recession, the way in which each different city and each different neighborhood within that city reacts to that is local, is different. It's based on how the community reacts, how the market in that place reacts, what kind of legal structure, policy, zoning, environment, all sorts of things. So one thing that this approach allows you to do is to have this broad view entry into this topic, and also would allow you to create very somewhat blunt ways of comparing these different urban spaces. But you always need to go to define detail and talk about specific places and the people who live in these places. Cannot only talk about buildings and cities and streets. And I always never forget about the actual people who live in these places.
Can I press forward on that in terms of how are you identifying these particular areas that you might want to look into the other, the cultural, the religious factors? Are you like honing in on particular parts of the city that maybe have the most dramatic urban change? I guess I want to know a little bit about your process of how you kind of
yeah. I mean, we haven't started much that yet, so that would probably we would do an analysis of urban change and use that to find places to zoom in and go more into detail about these different places within these cities. So I think that's what be the method. So my idea is even to go to some of these places, which up until a couple of months ago was not very possible because of COVID. And yeah, COVID disrupted a lot of my research, including some of these projects. They didn't progress in the way that I was envisioning them to progress before COVID. But yeah, when things come back to normal, I would like to go to all these places and do research there, do archival research, do some interviews, all the kind of things that. So it's going to be like a year's project. Yeah.
Thank you. Any other questions from the audience? I have one more, and then I swear to God, that's it. You talked about the method of annotating the images, right? And you demonstrated, or you actually showed some of the case studies that you used to be able to develop your own method. I'm wondering, especially with the use of Mechanical Turk. How did you address or deal with the potential of bias kind of influencing whether deeming a place particularly safe or not safe? Was there a way that you could have potentially ameliorated that bias that might have sneaked in?
Well, one of the ways that you do that is by, if you use Mechanical Turk and not like just crowdsourcing. I mean, if you use just a website that you ask people to do it, that's another way of doing it. But Mechanical Turk is, you're paying people to do that. One way with Mechanical Turk or something like that, you could do is to make sure the people who are going to annotate are geographically from places close to the cities or from these cities, so they know. So I don't want someone from Brazil annotating urban space in the United States and vice versa, because these are very different places. So what we hope that what we could get is the perception of the average person. So ultimately, you're talking about perception, not talking about the actual thing. So we're still thinking about that, about how to deal with the fact that we are talking about perception, but then we use other data to try to understand how much of that perception correlates with the actual thing. So if we're thinking about wealth, of course, you can use either household income or property values to do this type of comparison. And some of the other, like age, you could do that with, we can find renovation permits from a city to see how much of that correlates with the age, or like construction permits, how much that correlates with that perception of age. So there's a way of trying to do that.
Yeah.
Yeah.
So we have another question from Estela.
Yeah.
What tools do you use to geolocate a historical map? I mean, a very old map which may not be geographically accurate.
Okay, so in these projects, we don't geolocate any historical map. We do geolocate aerial images, and we georeference aerial images and geolocate historical images of cities. To georeference a map, it depends on the map. If you think about maps that were produced, let's say in the Americas in colonial times, a lot of times these maps have representations of space and conceptions of space that are very different from the ones we have today, these more Cartesian geometrical conceptions of space. So sometimes it's hard to georeference these maps in a very precise way. But their way in my work, I usually do work with from the 1930s on. So most of the maps that I use, that I have to georeference, are like more modern and cartographical. So they are easier to be georeferenced. So I never had to actually work with a colonial map. But there are ways of doing that. There's a project that I did that I used. It was not a map, but I used colonial post-modern inventories from Brazil from the late 18th century, early 19th century. And these inventories, they were like someone who was like a farm owner died, and then he lists his will or inventory, lists all the things that they possessed. And the location of the farm was really hard to find, the location of a farm in like 250 years ago. But they had the location of a village. So I managed to locate the farm by locating the village and establishing a buffer around the village. So my study was an approximate, where I would assume that the farm would be located within that buffer somewhere within that buffer, and I did some spatial study of land use and frontier, this expansion of agricultural frontier in this area of Brazil using this method. So you had to do some approximation when you work with spatial sources that are too old and that are from a time when people had other type of conceptions of space, or even like if they're from more present day, but are from communities that don't have the same Western type of conception of space.
Thank you. And I said, there's a tool, just to kind of put it out there, mapmover.net, that you can use to georeference historical maps. It's a relatively easy to use tool. You can always email me and I can walk you through it if you're interested. Well, the last comment we have, and I think it's pretty, I think it really finalizes the presentation, is, Cynthia, she said, thank you so much for presenting. It was really engaging and I learned a lot. And I think I echo, I want to echo her words. I definitely learned a lot. A lot of different methods that I definitely want to explore, but also just be able to impart and at least show your projects and your research to our students here at LLILAS Benson. With that, I really want to thank you for taking the time today to share with us your phenomenal work. It's pretty awesome work that you're doing. And yes, for those who are interested, we will be publishing this reporting online, and I'll be sharing it to our participants who registered at a later date. But again, I want to thank you again, Dr. Freitas, for sharing your work with us. And thank you all who were able to join us today to see this presentation.
Thank you for having me. It was a pleasure to be here.
Thank you again, and have a great weekend, everybody. And hopefully we'll see you in the fall installment of the Digital Scholarship in the America Speaker Series at LLILAS Benson. Everyone have a great day. Take care.